Imagine you're a doctor and you have trained a neural network to diagnose disease based on X-ray images. While the model may be highly accurate, you'd want to know what specific patterns or regions in the X-ray images it is using to make its diagnosis. Understanding this can be as important as the accuracy of the model. Having deep knowledge about something is crucial in the age of ChatGPT, which can write code faster than you or me. In short, in this video, we will produce class activation maps of our neural network and understand its importance. There are numerous libraries you can use to do that. TensorFlow has GradCam, PyTorch has Torchcam. But first, we will calculate the class activation maps from scratch to understand the underlying principles. Because
people don't have a clear picture of what knowledge is deep versus what knowledge is shallow.
Now for this video, we will produce class activation maps for cats and dogs classifier. We will be using the features learned from the second to last layer of the model, right before the fully connected layer. This layer contains the accumulated weights from all the previous layers, making it an ideal candidate for visualization. Now let's load our model. Preprocess image function will read our images with Pillow library, then transform it using the PyTorch transform method to feed into our model. Calculate class activation map function will calculate the class activation map taking the model and the image as arguments. Let's run inference through our image. Our feature map is in the dimension of 512 x 7 x 7. These are basically different features of our model. Each feature understands a different pattern through their hierarchical structure. This is also why CNN works so well with images. As you can see, the early layers of the model learn to detect simple patterns, while the later layers understand more complex features. This tells us how convolutional neural network works. They gradually build up an understanding of increasingly complex patterns. Now we will reshape these features into 512 x 49. We will fetch the weights for this corresponding feature map, which is in 512 x 1 dimension. Now let's do matrix multiplication between our feature map and our weights to obtain a weighted sum of our feature maps. The weights of our model decide which features are important and should be kept, and which ones can be ignored. The result of the multiplication will be in 1 x 49 dimension. So we will reshape it into 7 x 7 so that we can visualize it. At the end, let's return our class activation map. We will create our visualize function to visualize our image. As you can see, in this image, the last layer is focusing on the face, and again, in this image, it is rather focusing on the body because the face is not that visible. Now let's look at some real-world example where we can use the class activation map. In the case of diagnosis of pneumonia, you can see the model is focusing on the lungs. But for children heart defect, it is focusing on the heart. This insight could help you validate the model's reasoning and potentially catch any biases or irregularities it might have learned. Awesome! Now that we understand how to calculate class activation maps manually, let's explore a more efficient approach using Torchcam library. At first, let's install Torchcam and import layer cam. We need to pass our model as well as the layers we want to visualize through our layer cam. I am passing the very first conv layer to the last layer for ResNet 34 model because this is the model we trained. Let's preprocess our image as earlier. Generate output from the model. In this case, we won't need the feature map because Torchcam will do it for us. Run our output through layer cam, which is our cam extractor variable. This cams variable is the collection of all class activation maps for the layers we have provided. As you can see, conv1 layer has 112 x 112 shape, whereas the last layer has 7 x 7 shape. Now let's visualize each of them. Awesome! See, the very first layer is learning very simple patterns, whereas the last layer has learned complex pattern and completely focused on the relevant parts of the image. In summary, class activation maps are a powerful tool for interpreting and validating the decision-making process of neural networks, especially in image-based tasks. By visualizing the areas of focus for different layers, we can gain valuable insights into the model's learning and potentially identify any biases it might have. Remember, understanding how our model works is just as important as achieving high accuracy, as it helps us build trustworthy and reliable AI system.